Hello everyone and welcome back to another video provided by SVSU's Online Tutoring. My name is Joel and today we'll be continuing on with section 8.5, Applications for Quadratic Functions, or with Quadratic Functions, and the topic for this video will be on reduced rates and the Pythagorean Theorem. So what I've done is that I've put in the problem statement and the setup along with the list of the variables. So what we want to do here, or what the problem statement says, is that a ski club charters a bus for a ski trip at a cost of $1,000. But when 10 non-members accept invitations from the club to go on the trip, the bus fare per skier decreases by $5. And so the problem wants to know how many club members are actually going on the trip. So right here is the thought process behind setting up our quadratic equation, is that we want the fare per skier, and then multiply that by the number of skiers, which will equal the fare price. Okay. And so what we do is that we identify our variables. So we have the number of members actually being x. Okay. And then the total number of skiers is x plus 10. So we have the number of members plus the 10 non-members. And so the original price per skier would have been 1,000 divided by x, but since we have non-members going on, it's the original price minus the $5. So it'll be this variable multiplied by this variable right here, the number of skiers. So we have 1,000 divided by x minus 5 multiplied by x plus 10, which equals 1,000. And so what we want to do, all we have to do is just FOIL this out. And when we do that, we end up with 1,000 plus 10,000 divided by x, and then 5x minus 50 equal to 1,000. And so the next thing that we want to do is just combine the like terms real quick. So we have this. And the next thing that we want to do is get rid of this x in the denominator here. So we have to multiply both sides by x, or just multiplying the entire equation by x. And then we want to subtract this 1,000 on both sides, so that way we can solve for x, or find its zeros rather. So let me write it with the leading polynomial up front. And then the next thing I'm going to do is I'm going to divide everything by -5, because all these terms are divisible by 5. So we end up with x squared plus 10x minus 2,000 equaling 0. And this is actually factorable, and the factors that we end up with are x plus 50 and x minus 40 equaling 0. And then we just solve for x by setting each of those equal to 0. And so x is equal to -50 and positive 40. So obviously we can't have negative members, so we reject that value. And so we say that x is equal to 40, or that there's 40 ski members. Okay, and then we can move down here for the Pythagorean theorem problem. So what I did here was just I went to Google Maps and took a snapshot of SVSU. So right up here, let me see, I can get this in yellow. Right up here, this is supposed to be Brown Hall, and then right down here is the marketplace, okay, or that side entrance to the marketplace. And so you get out of class and instead of walking the distance that it takes to get there, what you want to do instead is just cut along the grass. And you find that that distance is 450 feet, okay? And walking along these two paths here, right, would be, you know, some unknown amount of feet in the horizontal direction, and then 500 minus x feet in the vertical direction, okay? And so you want to find out how long the legs of this triangle actually are. So what we have to do is that we have to turn to the Pythagorean theorem in order to solve for this. So we have a squared plus b squared equaling c squared. And so you just have to remember that the legs of your triangle, so these two guys, can either be a or b, and then c is the hypotenuse. So c right is the hypotenuse right here. So all we have to do is just substitute those values in. So we have 500 minus x squared plus x squared equaling 450 squared. And so then we have to expand everything. And when we do that, we end up with 2x squared minus 100x plus 47,500 equaling 0. And so this isn't factorable, or well, it's really not a nice factor, nice thing to factorize. So instead we turn to the quadratic formula to solve for x. So that has a form of x equaling negative b plus or minus the square root of b squared minus 4ac divided by 2a. And so if we substitute everything into there, we'll have negative times negative 1 times negative 1,000 actually. So up here it's supposed to be 1,000. And then plus or minus 1,000 squared minus 4 times 2 times the 47,500. Throw in an extra 0 there. And then all of this divided by 2 times 2. And so when you do that, you end up with x being equal to 25 plus or minus, 25 times 10 plus or minus the square root of 62. And so when you evaluate both the plus and minus, you find out that they're both positive, so they're both positive numbers. And we can just take a look at just one of them. So 25 times 10 plus the square root of 62 is approximately 446.85 feet. Okay, and then so I'm just going to round that to 447 feet. And so that's what the length of B is. Okay, B is equal to 447 feet. And so then to find out how long our A is, we just take 500 minus 447, and we find that that is 53 feet. And so the thing to keep in mind here is that since both of our solutions for x are positive, all that means is that the legs in our triangle would be switched around. But both answers would be right. It would just mean that this picture's like not to scale, or it just looks funky. Okay, that does it for this video. We'll finish up with section 8.5, and that will be on I think related rates, or let me take a look actually at it. A work rate problem, yeah, a work rate problem, and then the rocket problem. Okay, see you next time.